So before jumping into this, you might wonder, why C++? Isn't there anything on npm? Can't we just use a module? So if you look at the state of the art on npm, from the research that I've done, I've found that the functionality you can get is playback and recording of audio. So there's no real time, no chance to modulate the pitch of a sound, no chance to add reverb to a sound, no chance to write your own DSP blocks and run them. So npm isn't really a viable option. I can also refer you to Tom Dunkhoff's talk from Rowley. He did a talk on React Native at the Audio Developers meetup recently, and he explained how to connect Juice into your React Native app. So there's another talk there that I can kind of give you a link to. So yeah, the summary there, there's no real-time DSP control from JavaScript on npm. Yeah. Okay, so yeah, we will have to build our own bridge module. So who's worked with the React Native bridge before? Cool. So the React Native bridge, all of the React Native UI goes through the React Native bridge. So whenever you change a prop on your JavaScript, if that needs to make an update to the native component, then it will go through the React Native bridge. But you can also create your own React Native modules, React Native bridge modules, which will allow you to communicate down there on the same bridge as the rest of your UI code. Yeah. So also, key part of this, picking an audio engine library to use. So I'm going to give an overview of 3 main libraries that I could recommend using. Out of these 3, I've used 2 of them, and Juice is the other one. So I can refer you to Tom Dunkhoff's talk for that, because it's very good, and you can see how to communicate from React Native to Juice with that talk. Okay, so also, probably gone over this a little bit, but why C++? So obviously React Native is cross-platform. We're looking to deploy to iOS and Android. So C++ C code is cross-platform. So if you write your audio engine in C++ or C, then you're going to be able to run that on Android and iOS. I can only talk from experience with iOS, but I know that the libraries that I'm recommending here definitely run on Android as well. There's a lot of examples of them running on Android. So also another reason to use C++ or C is the performance. So for real-time audio processing, it's very important, the performance. You can get into a situation where if you have a performance problem, your audio will pop, or there will be kind of clicking or choking in the audio. So that's another reason why people use C++. And the third reason, so building on established code bases. So if you look on the Juice forum, or if you look on online DSP forums, a lot of the examples are C++. I mean, I work with some DSP engineers at work, and they all use C++. That's their language of choice. So I think the community is there, and that's really the language that people are using. Okay, so the first library that I'd like to kind of present to you today, it's called Superpowered. So it's a cross-platform audio engine library for iOS, Android, and also wearables, desktop. It runs on several different platforms. So the pros of this library, I would say out of the 3, it's the quickest to get started with. It's got a high-level C++ API. You can get straight in and you can create. You can open up an audio source, and then you can tell it to loop between 2 points, and it will just constantly loop between those points. I mean, that's quite a high-level API in terms of how C++ DSP code works. It's not coupled to the UI by default, so it's just audio engine code running inside of an audio processing callback using core audio unit. So all the core audio code is open source. I can also say that it allows you to plug in existing DSP blocks. So if you're working with a DSP engineer, they're used to this place where you have an input, which is stereo, two channels of floating point data. So that's your sample data. And then you process that data and you output another stream of floating point sample data. So this is how Superpowered's audio processing callback works. The buffer is input as floating point stereo audio, and it's outputted as floating point stereo audio, so it's great for that. There's lots of features built in, so there's filters, there's an audio source, there's an FFT plugin, there's echo. I've talked a bit about the looping. There's an extensive API there. The cons of this, it's licensed, so if you want to use any of the audio streaming stuff inside of there for HTTP streaming, there's a fairly chunky license fee there. Also, the API has its limitations because it's so high level. You might not be able to, with the audio source, you might not be able to get right in there and write your own custom code because it's offering you quite a high level API. The code base is closed source, so all you get is a compiled static binary, a .a file that you can run in your iOS app, but you won't be able to look at the source code. It's impossible. So the next one is Juice. So the pros of this one, it's got a very large community. The Juice forum, you can go on there. There's all sorts of different examples that people have posted. There's like question topics about React Native. There's question topics about different types of DSP blocks you might want to build. So yeah, I can definitely recommend for a community the Juice forum is very good. So again, it allows you to plug in existing sample level DSP blocks. So yeah, if you've got some code that processes sample data, you can plug it straight into your Juice audio processing callback, which is kind of similar to Superpowered in that way. But yeah, so the license also, it's pretty cheap with Juice. It's just like £1,000 for a developer license, so it's not so bad. It's like, I think that's lifetime. So yeah, it's okay. You will find that with a lot of these libraries, but I think there's only 3 main ones, but they're looking to license it. They're looking to either for you to put the logo on the splash screen of your app, or for you to pay them because the code is I suppose they value it. So it's a very large framework, so it might take some time to get started with it, and also it's a lot of what it's used for is making plugins. So if you've ever used Logic Pro or anything, in the digital audio station sort of space on your Mac or on your Windows computer, you probably have been using Juice if you're using any third-party plugins, because most plugins that you see in digital audio workstations are built with Juice as a sort of framework to get started. So yeah, I would recommend this talk on Skills Matter for building a React Native app with Juice. So that's really good. So I went to that talk, spoke to Tom Duncalf, and yes, definitely recommend that. And the third one is my favorite at the moment. This is Gstreamer. So Gstreamer is a framework for multimedia pipelines. So it's got a lot. It's not just built for audio processing. It's built for video streaming. It's built for video processing apps. If you want to build something like Premiere Pro, you could start building it with Gstreamer. Yeah. So the pros of Gstreamer, it's got a high level API and a low level API. So what do I mean by this? Getting started, you can write node-based DSP. So if you've ever used the web audio API, used to maybe creating web audio nodes, connecting them together, you can do the same thing with Gstreamer. Once you get it set up, you can get elements from their plugin registry, link them together, and I'm going to give a demonstration of this shortly, where you can see an oscillator running into a sample converter, into a reverb, into a volume, and then out into the speakers. So, I mean, that's actually fairly trivial, I'd say, once you've got it set up, which is pretty nice. But then it also has a low-level API, so you've got control over threading. You can write your own plugins to process sample data. So, yeah, it's definitely I think pretty useful. So it's not coupled to the UI by default. You'll find with Juice that by default they've got their own kind of UI framework built in, and you'll have to give React Native the root view of your Juice app to get it running. That's the advice that you'll find. So yeah, it's better not to be coupled to the UI in my opinion, especially working with React Native. So again, yeah, there's some powerful features built in. The node-based DSP, I've got to say, getting started, it's really great. You could build a synthesizer with it without actually, writing your own reverb. For instance, you can just plug the free verb in, which is a like well-known open source reverb. So yeah, it's using the LGPL license. So what does that mean? It means that you can take the code, build your own app with it, and then you can distribute that app, and you won't have to put their logo on your splash screen. You'll be able to basically take that software, build your own software on top of it, and then you can sell that software. So that's definitely an advantage. The cons, it requires you to write some C code, so that can be a bit scary. The pattern is not necessarily what DSP engineers are used to, because to actually put any sample level DSP into a Gstreamer pipeline, you're going to have to write your own Gstreamer plugin, which is, again, something certainly I haven't been able to do yet, and it's not something which DSP engineers generally would do. They would use an audio processing callback. Yeah, so that's option number 3 out of the 3 audio engine libraries that I'd recommend using. So I've got some experience using Superpowered and Gstreamer. I've had a play about with Juice, but not that much. So if anybody wants any more information about this, yeah, just ask me maybe questions afterwards. So yeah, getting started with actually building your own module, it is going to take, opening up Xcode, opening up Android Studio, creating your own React Native Bridge module and getting in there and getting some C code or some C++ code to compile, basically. So that's just, introduction there. In terms of installing any of those 3 libraries, I'd be happy to maybe answer a couple of questions afterwards, but I think it's about an hour talk just to kind of run through properly installing those libraries. So I've just put these links to some resources where you could maybe find out, where to install React Native with Juice, where to install or how to install Gstreamer, or how to run the Superpowered SDK iOS examples. So then you have to kind of go through those Xcode projects and look through how they're compiled, and then kind of pick it out and create your own React Native module from that. Okay, so I would also recommend this module on NPM to get started with. So React Native Create Bridge. So this plugs into the React Native CLI once you install it. So that allows you to then go React Native new module as a command through your terminal. And then you can choose if you want to create a UI component with Objective-C or Swift, if you want to create a UI component with Android or Kotlin, with Java or Kotlin, and then also if you want to create a bridge module with either of those platforms. So this is really good. I've used this in the example that I'm about to show. So both the UI components that I've written with Objective-C and also the audio engine, the bridge for that's all set up using this library just to help me kind of get the initial communication going, template out that bit of bridging code quite quickly. So yeah, highly recommend this. It's saved me a lot of time, started using it recently. So a little bit about the communication before we look at the example and some code. So we've got the bridge modules which are used, you can create a method with the RCT method macro on your Objective-C or Java code, and that exposes the method to JavaScript. And then you use the native modules within React Native, which is you can export from React Native in JavaScript, and you can then access that method. So you can use methods to talk down to your native code. To talk back up from your native code to your JavaScript code, you use the native event emitter. Yeah, there's also callbacks on the methods, on the method macro, but the callbacks is pretty much the same as an event. I don't recommend the callbacks. So this is a bit of a small part of the app that I've just shown you. So over here, we've got a method, a C++ method called update coordinates. I couldn't quite figure out what else to call it. It's kind of binded to the UI there, but it takes the X and Y from the position on the screen and passes it into the engine. So using the X and Y data, which is passed through the bridge, is setting the frequency, setting the room size on the reverb, setting the volume. So then this is a React Native method macro. So I'm exporting a method called, again, update coordinates. The types come in as NS number. So with this kind of communication, you need to convert types from NS types to C++ types. So that's what we're doing here. We're just converting that, getting the double value out of the NS value. So we're now getting a C++ double value and passing it in. And on the JavaScript side, you pull in the Gstreamer bridge from native modules, like I said, and then handle move is controlled by the touch position using pan responder from React Native. And then it updates, it calls the update coordinates method, which controls the kind of effect that I just showed you where it's pitching up and down. Yeah, so that gives that kind of slightly chaos pad-like effect on the audio there. Yeah. So any questions on this? Maybe afterwards we can talk a bit more about it. I can show some more code examples maybe. And then this is so that's the default way of doing this. So you create a method for every communication you want to make. So that would mean creating a method macro for the play method, method macro for the pause method, a method macro for the set waveform method macro for the update coordinates method, and then for the init method. You're going to end up writing quite a lot of Objective-C code and ending up, that's going to be a maintenance burden. Every time you want to add a new value, you need to convert from NS type to C++ type and down. It's not ideal, really. It's a bit too much boilerplate, I would say. So this is an example of maybe another pattern that we could use. Again, this is running in that app that I've showed you there. This is actually, running code that I've been using. So basically, what's going on here? I've set up a new method on the React Native bridge that takes in two arguments: NSString, the message type, and NSString message JSON. I've missed that out of that slide because it's quite similar to this. It's just getting NSString as one argument, NSString as a second argument, the message type and the message JSON, and then passing it. It converts it to a stud string and then passes it directly into the C++. So that's the only method that you would need to write using this pattern, and then everything else can be handled from C++. So this C++ method here, it takes in stud string, message type, stud string, message JSON. If the message type is init, then it sets the state to be that value, which is passed out of the string into a JSON value. It sets the waveform from that JSON value that's been passed in. So this is like your initial state, which is configured from JavaScript, but is mirrored in your C++ code to keep the same state in your C++ as you would have in your JavaScript app. And then at that point, early return, because we don't want to hit this code, the merge wouldn't work. But then on the second message, the play message, sending in some more data, is playing, which isn't actually used. But in that case, we're passing the new message and merging it into the old state. So it's in a way like a Redux store, you'd merge in the new state in a way, So you're keeping the state synced from your JavaScript to your C++ in this way by merging in the small state changes that you need to make with every request to the engine. And then from there, we're just getting these values, which are used later down the function, but I've taken it as far as here where you call the play method and it plays. So on the JavaScript side, just a little bit of an example of that. So the state update is playing is true. JSON stringify that, send the message down, play type, and then that's going to send it through to this process message method. We merge in the new state just to keep everything synced up, basically. So the questions that I'm kind of asking here is Java and Objective-C detrimental to the success of your project? Because JavaScript and C++ are cross-platform. So in this way, you can literally be working on two sides of your code base, your JavaScript and your C++, and not touching the Objective-C, which is really nice. I'm quite fond of this pattern. I think potentially it's not performant enough because we're adding another JSON encode and JSON parse, which is what React Native is doing anyway, but doesn't matter for a play or a set waveform, but it does maybe matter for the real-time frequency update that you see in the audio app that I've shown you. In that case, you might want to just create a special one bridge method for that particular request because it's a high frequency request that you're making. And then this is an example of sending an event back up. So this is using the native event emitter. You need to extend from the native event emitter class when you create your bridge module. Actually, the npm package that I showed you will do this for you. So you'll be okay. You can actually call send event with name, which is the method that the React Native event emitter exposes for you. That's going to be set up for you pretty much by default if you use that package. So it can take you a little bit further instead of having to set the class up yourself. It'll set the class up with all the right kind of extensions from different base classes. So yeah, you have to set the supported events. You have to list them out in an array. Otherwise, it will fail and it will show you a red screen on React Native, and then it won't work. Basically, you'll have to go in there and find that error and fix it. So then, yeah, this is in the component. The amount is just adding the listener, setting the level on the state. So then that actually uses to update the UI quite stupidly in this example, just to show kind of how busy the bridge can get if you try and just communicate directly between JavaScript and C++ and do all your UI rendering from there. Yeah, so those are the 3 things to look at, I would say, is creating a method to pass down data to your audio engine, maybe minimizing the amount of non-cross-platform, so Objective-C or Java code that you need to write, and then finally sending events back up to your JavaScript to communicate from your C++ to your JavaScript. Yeah, so those are the code examples. And then this example I've also added is a way of maybe getting access to your bridge module from a native component, for instance. So you can get access to a shared instance of the RCC manager, get bridge. That's the bridge, that's the React Native bridge in native. And then it's going to show you, can you get this module? Okay, if the module's there, then get the instance of the module. So instead of using a singleton, we can get the one instance that React Native is managing for us. React Native has its own garbage collector built into it, so it's probably better to let them manage the memory of your native modules for you. Yeah, so that's that bit. And then when the bridge is busy, there will be increased latency with your JavaScript. So as soon as you build a large React Native app, the bridge will get a little bit busy. I mean, we know from experience, our bridge does get busy with. You have to optimize it and minimize the amount of communication, and also the amount of data that you're sending over. It's pretty important because everything's getting JSON encoded and then JSON parsed. Yeah. So also just a little note on the future ideas. So I just want to put this idea out there that it'd be really cool to build a React Native module on NPM using Gstreamer. So you could create your own kind of pipelines, script them from JavaScript, and then send them down, and it would create them for you. This could be kind of similar to the Web Audio API. It's got most of the components in it. Also, Gstreamer is used in WebKit to write the Web Audio API, so I think it would be a good fit. And then finally, there's this link here, which I can't really show you now, but it's basically a sample C++ module within React Native source. So they're not publishing this on any blog post yet, but you will be able to create your own native modules directly from JavaScript to C++ without writing any of that bridging code at some point, I would say, in the future. And this is something that the Juice team are working on as well, and the Roy team. Yeah. So any questions? Any questions are welcome if I can answer them. Yeah. That's the end of the talk.